Hi there, thanks for joining us. This is Space Nuts. I'm your host, Andrew Dunkley. Always good to have your company. Coming up on this episode, we will be looking at fire and space. Not usually two things you want to put together, although stars are technically fire in space, but we're talking about fires on spaceships. You don't want that, but NASA's been looking into it. And a glowing space cloud could be a clue to an ancient planetary collision. We'll look at those things on this week's episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me again is Professor Fred Watson, astronomer at large, to look at all of that. Hello, Fred.
Hi, Andrew. How's it going in your neck of the woods?
It's been hot and muggy. We've had all sorts of. We've had just about every season there is over the last few weeks. It just ever changing. I think we've got that tug of war between seasons where summer's saying I'm not letting go yet, and autumn is saying, yeah, I want my piece of the pie. So it goes backwards and forwards. Some days are very, very hot. Some days are very, very mild. But I think autumn will fall into line soon. Boom, boom.
Yeah. This is why a lot of different First Nations peoples in Australia have more than 4 seasons, and it's because of exactly that.
Yeah. I mean, we've basically created 4 seasons, but it doesn't really glean that way a lot of the time, does it?
Not when
but what would you call
them.
extra ones?
There's many different Aboriginal names for those marvelous extra seasons. That's very interesting stuff.
Yeah. It is. Yeah, I'm going to have to read up on that. Fred, let's get down to business, and we're going to be talking about fire and space. And, of course, fire does exist in space in the form of, stars. But that's a natural phenomenon. We're talking about unnatural, man-made fires on spaceships and rockets. And there have been some famous cases since the space race began. I suppose the most infamous of them was the fire in the capsule of Apollo 1, an oxygen issue, I believe. But there was another one that I read about that I didn't know existed, and that was on the Mir space station back in 1997. They had a fire that threatened the space station and the crew. Fire in space just doesn't work well together at all, does it?
It doesn't. I'm going to step back a minute because we're going to get listener comments about this if I don't.
Okay.
Stars are not on fire.
Oh, well. But they are. It is a fire, isn't it? There are flames.
It's just a very, very hot object. So fire technically needs oxygen, and a lot of people do say that. How can the sun burn when there's no oxygen in space? But it's not burning. It's just a ball of gas that's heated by nuclear fusion, but it's not on fire. So somebody would have come in.
Yeah, I know they would. I know. Yeah.
But to cut to the chase, the kind of fire that you're talking about in the inside a spacecraft, yes, is not good news. And so it has been the purpose of a series of experiments run by NASA. They're called Sapphire. I'm not sure, it could be Safe Fire as well, because it's SAFFIRE, so Safe Fire might be a better way of saying it. But the Sapphire has been actually, it's a 6-phase experiment, each of which has had 19 runs of fire, where they've tested, basically the flame properties of lots and lots of different materials, including plexiglass, what we call perspex, cotton, Nomex, and something called solid inflammatory boundary at low speed fabrics. There you go, a class of fabrics that are obviously there to stop fire spreading. What they've done is they've had this unit, which is about 3 feet by 4 feet, in which they test these various materials by setting them on fire with a camera inside, and it's actually a wind tunnel. So the vehicle in which these experiments are carried out, which is not the International Space Station, you'll be glad to hear. It's one of the Cygnus vehicles that is used to supply the International Space Station, and in fact, it's usually on the way back where this vehicle is going to burn up in the atmosphere anyway. So they run the tests then, and basically, this unit is a wind tunnel, so it's got an airflow through it. And you can change the proportion of oxygen in the air and things like that, change temperature, change all the various factors, and look at the heat release rate that's coming from them, and work out what might happen if such a fire occurred actually in a space vehicle. And so this is the last one that was conducted just a few days ago during one of the returns of a Cygnus supply vehicle. But what an interesting thing to do, to use what resources you have to basically in the long term enhance mission safety and essentially feed that back into designs. And you're absolutely right, that everybody has in the space industries has got echoes of the Apollo 1 fire, which was when Apollo had a pure oxygen atmosphere, and that's what basically put a stop to that, that it's more rich in nitrogen.
Yeah, and it changed safety protocols thereafter and on several levels. But pure oxygen caused the pressure to rise to 29 psi, which ruptured the command modules in a wall. Flames and gases then rushed outside, and the command module through an open panel. And the rest is history. It caught them completely off guard. They couldn't get out. Terrible tragedy. But there was also a fire on the Mir space station in February 1997. There was a crew of 6 on board at the time, and they were in quite a deal of peril when the fire ignited. And again, it was oxygen, an oxygen generating system. The flames lasted several minutes, which they managed to get under control. I think I don't know exactly how they got out of that one, but I think they cut off access to the Soyuz escape vehicle, so they couldn't get off. Very perilous situation indeed.
Yeah, and I guess just to illustrate how much things have changed by the fact that we now understand controlling fire much better in a spacecraft. The Tiangong space station, which is the Chinese space station, back in September, 2 astronauts on board the Tiangong station, during a live broadcast from the space station, they lit a candle. And so, that's really just to demonstrate that things have got much safer now than they were. I'm not sure how long they let it burn for. I'd have been blowing it out very quickly, I can tell you.
Yeah, indeed.
But they lit a candle.
Yeah, I'd be resistant to blowing it out because
that's right.
You could blow the flame onto something in a zero-G environment.
Yeah. So you pinch it. That would be the way to do it, I'm sure.
That would be the way to do it. The old wet your fingers and pinch test.
That's right.
I think I remember in the movie The Martian they portrayed an issue with fire when he was trying to create water for his potato farm. While he was stranded on the red planet, and used I can't remember the name of the system, but he blew himself up the first attempt because he didn't allow for the oxygen he was exhaling in the calculations to balance the fuel and the burn. And so the extra oxygen created an unstable environment. And so when he basically fired the spark to get the whole system going, the whole room exploded. It was actually very cleverly explained. I don't know if it would really happen that way, probably, but I don't suppose it's so easy to forget that when you're breathing, you do actually
Yes, you
exhale
exhale.
oxygen, and
Because
that's
it's
where
not
he
all
got himself into
converted to-
trouble.
Yeah.
Yeah. So the solution is just to keep doing tests and to keep trying to come up with ways of reducing the effect of fire, because inevitably there will be fires in space. I dare say there will be
that's
times
right.
where accidents will happen. You can't say it will never, ever happen. And in the confines of a spaceship, and that was with the Mir space station, I said there was a crew of 6. It was actually a changeover period. It usually only takes, only usually has 3 crew, but they were doing a
that's right.
changeover, which made it even more complicated under those circumstances. But and apparently the toxic smoke got into the systems that create their oxygen, and it was pretty hairy. And you've got nowhere to run. I mean, in space, you can't run outside and wait in the street for the fire brigade. You've got to figure it out yourself.
You do.
I imagine the training, Fred, that they go through for as astronauts and cosmonauts, and all the other countries that are sending people into space these days, you would spend hours and hours and days and weeks and months looking at all possibilities and cementing it in your brain as to how to deal with these situations.
I'm sure that's right. I mean, we know what what kind of training aviation pilots go through, and to meet every possible circumstance. Actually, even when Marnie was doing her flight attendant training, that's incredibly intense. It's all about safety and reacting to situations and things of that sort. You do months and months of training and learn how to make a coffee on the last day or something like that, because everybody thinks it's serving coffee. But aviation generally has similar kind of protocols, but in space, exactly as you've said, they're carried to much greater extremes. So the training of an astronaut would be very, very significant.
Indeed, it would. When we were growing up, being an astronaut was every child's dream, and every boy's dream probably, but it's not exclusive to males these days, of course, and that's rightly so. But the astronauts were few and far between, and cosmonauts. These days, you could probably pass a few in the street and be none the wiser. It's becoming a more common job now.
Yeah, something like, I haven't looked at the numbers recently. It's well over 500. It's probably maybe even 700 people who've actually been into space now. It's a large number, yeah.
And I think it's going to keep on growing, and it'll reach a point probably in the next 50, 100 years maybe, where it's, people are living and working in space for long periods of time, space stations, space tourism. I think it's got to happen that way. Ultimately, and I wonder who will be the first baby born in space. That's definitely going to happen.
Yeah. So all of
I
this
reckon.
learning about fire in space is feeding directly into all that. I'm sure that's right. It gives us, confidence that we can cope with these things.
Yeah, coming up with new safety protocols and new materials that are fire retardant and new extinguishing systems. They'll just keep working on it. Yeah, it's fascinating. And if you'd like to check out that story, it's on the phys.org website. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, to our next story, which is a bit of a mystery, but it looks like observations have come up with a reasoning for this. But we're talking about a star that was bright and then it wasn't, and they sort of looked at the data and went, hang on a minute, something different's happened here. And we're talking about an eclipse that lasted 500 years in this case. So obviously...
500 days.
500 days, sorry, I'll just say years. 500 days. So these space scientists had to be very patient to figure this one out.
That's right. Although as I understand it, Andrew, this discovery has been made largely from what we call archival data that were taken by, by a telescope system of some sort of which is archived. It's freely available to the astronomical community. That's how fast radio bursts were discovered, by scientists trawling through archival data from the Parkes radio telescope here up in northern western New South Wales, Mariang. The telescope in question in this case was something called WISE, which is something like the wide-angle infrared survey experiment. I can't remember the exact acronym, but WISE was a spacecraft that, as far as I know, is now no longer operational, but was run by NASA, and it's as the name implies, it's an infrared survey telescope. But what's happened is a large group of scientists, actually, and I think most of them are based in Leiden in the Netherlands. And they're led by somebody I've worked with, actually, a guy called Matt Kenworthy. So it's really nice to see his name on the paper, which is in Nature magazine. So that's a top-line journal to have this published in. The paper is entitled "A Planetary Collision, Afterglow and Transit of the Resultant Debris Cloud." So that gives you the story, but in gobbledygook science speak. So what they've done here is taken observed data on, it's actually a sun-like star, but much, much younger than our sun. It's only about 300 million years old. And so it probably is surrounded by, a protoplanetary disk or something like that. So young planets are being formed, and we know that in the sun's, within the first few 100 million years of the sun's history, everything was banging into everything else. So Mars was, how the moon was formed. It's probably how Uranus fell over. All of these things are the result, we think, of collisions in the early history of the universe. And so looking at a star that is going through a similar period can be very instructive. And sure enough, when they did look through these data, they found stuff that is very instructive. In other words, evidence of two young planets colliding, and they're big ones too, by the sound of it, from the analysis. So what happened to it? It basically, the star was very bright in its infrared luminosity, because it's an infrared telescope. So it brightened up over a period of 1,000 days. But there was, to start with, a spike in this increase in brightness. So what happens? There's the star behaving normally. Suddenly, its brightness increases with a spike, but the brightness remains high, even though there was an initial spike. And it actually lasted for about 1,000 days. But about sort of, something like, I guess, 2/3 of the way into that, was suddenly a dimming of the star, and that caused a dip in brightness, which itself lasted for 500 days. So there's a sort of dip overlapping this brightness in luminosity. And what they think has happened here is, well, they put this all down to a glowing cloud of gas and dust. And dust is, some infrared wavelengths, dust is very luminous because it's warm. And the longer wavelength infrared is heat radiation. So what they think was that two newly formed planets, one of which they had the detail that it may have contained ice, and that's by the analysis of the infrared spectrum that you're looking at of this gas cloud. Anyway, these two giant planets, somewhere they're probably bigger than Earth, maybe multiple Earth masses, crash into one another, and that creates a glow because of the heat released, but then essentially produces what they think would be a molten core, surrounded by a large cloud of gas and rock and dust, the debris from the collision. And that's sort of continues to orbit the star, and eventually it moves in front of the star and darkens it. So that's how they've got both a brightening of the star and a dimming of the star. Now, I think there was a ground-based survey that first picked up this star, but the data, most of the data have come from the WISE mission, as I mentioned. I might just read a little bit from the abstract of the paper itself, because it just gives a few more details. So this is that Nature paper I mentioned, Kenworthy et al. Planets grow in rotating disks of dust and gas around forming stars, some of which can subsequently collide in giant impacts after the gas component is removed from the disk. And so, here we report combined observations of the young, about 300 million years old, solar-like star, ASA-22QJ, an infrared brightening consistent with a blackbody temperature of 1,000 degrees Kelvin, that's above absolute zero, and a luminosity that is 4% of that of the star, lasting for about 1,000 days, partly overlapping in time with a complex and deep wavelength-dependent optical eclipse that lasted for about 500 days. And so they say the optical eclipse started 2.5 years after the infrared brightening, implying an orbital period of at least that duration. So what they're saying is it's got to have more than a 2.5 year of our own years. And then they say the observations are consistent with a collision between two exoplanets of several 2 tenths of Earth's masses at 2 to 16 astronomical units from the centre of the star. Remember, an astronomical unit is the distance of the Earth from the Sun. Such an impact produces a hot, highly extended post-impact remnant with sufficient luminosity to explain the infrared observations. Transit of the impact debris across the disk of the star, sheared by orbital motion into a long cloud, causes the subsequent complex eclipse of the host star. I can't read anymore. But what a great summary of a really interesting observation, something that, it's like many of these things, it's serendipitous, it's unexpected.
Yeah. Now, I did find the what WISE stood for, Wide Field Infrared Survey Explorer.
Okay,
the name of that.
Got the Explorer wrong.
Yeah, you're pretty close. What's going to happen now? I mean, they think these two planets basically smashed into each other and caused this heat and cloud.
Yeah.
What happens next? Will they fuse together, or will they create moons, or what's likely to be?
Good point. Yeah, there might be moons. So it sounds as though the core of this newly created planet, which is still molten, we think, is in orbit around the star. But as they say, that the debris disk has been stretched out, probably into something banana-shaped. Transit of the impact debris, sheared by orbital motion into a long cloud, causes the subsequent complex eclipse of the host star. So that long cloud of debris could itself coalesce into smaller objects, maybe moons, if they're gravitationally bound to the remnant caused by the collision. It's kind of watch this space. We need probably 10 to 20 or 30 million years to see what's really going on, but it's definitely going to be worth keeping an eye on.
Yeah. I was going to say we probably have to be very, very patient to see all this transpire. Could maybe some of that debris cause a ring around?
Well, that's a good suggestion. Yeah, there's a good chance of that as well. You're on the money there, Andrew. You're firing on all cylinders. I
got off to a slow start, but I'm making a comeback. I'm fascinated by the fact that they can figure all this out from historical data. And what sort of a distance are we talking about from Earth? Do we know how far this is away?
We probably do, but I can't remember what that was actually. Let's see. Have we got a distance?
Because it's another astounding thing that they can take historical observations from something that's obviously not anywhere within our vicinity, and put together I don't know, a sequence of events that they think occurred. I think that's incredible science.
Yes, it's the best of astronomy, really. You know, astronomy generally needs. It would be lovely if we could go and touch things and do experiments on them, but we can't. So it always needs radiation or particles that have transferred across the void between us to actually work out what's going on. I'm just trying to find its distance from what we know. It is 1,850 light years away. There you are.
There you go.
It's the constellation of Puppis.
Oh, okay. Yeah, where Oumuamua came from. Boom, boom. No, I'm kidding. The space doogie.
I know, I get it, yeah.
You walked into it, Fred.
But I did, yeah. I'm usually careful. Puppis translates as the poop, but usually I say it's the poop deck, because it's one of the three constellations. The giant ancient constellation of Argo Navis, the ship Argo, was broken up into Puppis, Vela, and Carina, and Puppis is the poop deck. But it's a hard one to say if you've got a bunch of school kids in front of you.
Yeah, don't go down that road. It reminds me many, many years ago when I had to go to a school in Mudgee, and they had a few guest speakers, and I was invited to go along to talk about radio. And I told them about a time where I was on air and I opened the microphone and I could just feel a little something, and I thought, I'll just deal with that before I start talking. It was a bit louder than I expected, and there was this went to air. The kids loved that story. They absolutely loved it.
Well, I bet
but it's true.
Yeah,
it happened. And of course, I had to try and keep a straight face because it was just a fraction of a second before I started talking. And you're listening too. Yeah. Anyway, it makes a good yarn when you're doing guest speaking gigs.
I wondered where it was. Yes, it would. I wondered where it was in your career where you lost all credibility, because I've had several points like that.
Yeah, pretty much then.
Very good. Very good.
It certainly broke the ice at that little Q&A, I must say.
It did, yeah.
That story is available at the NASA website, science.nasa.gov, if you want to check it out. Fred, that brings us to the end of this particular show, and people are going, hang on a minute, what about the Q&A? Yes, there's Q&A, but we've decided to do them as two separate shows. We've been experimenting with it recently. So never fear, you will get the second part or the new episode of Space Nuts Q&A on Mondays. So, we're doing two versions, mainly due to listener feedback, because people want a more bite-sized version of the show. So we're going to split it into two shows for the benefit. And of course, you can still listen to the whole thing, lock, stock and barrel, if you wish, through Patreon. But yes, in general terms, we're going to be doing two shows a week, but you'll still get the whole thing as you used to, just in two parts. So, Fred, thank you so much, and we will catch up with you on the next episode of Space Nuts.
It's very good. Very good to talk, Andrew. Thank you very much.
I'll see you soon. Fred Watson, astronomer at large, and thanks to Hugh in the studio. Hang on, let me see. No, he's not here. Okay. And from me, Andrew Dunkley, see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.